morning, everybody. 6:47 a.m., December 12th, 2017. Alright, I have a Navy.nrl webpage pulled up for you. This is a water vapor chart. I use this a lot during the hurricane season, but I'm going to use this as a good example to explain what's going on with this lake effect snow. If you remember my last video, we had a system that passed through that was expected to hit Buffalo and Watertown especially, but those areas that got the most snow ended up being a little bit south of there. Now, a few people were asking questions about how a dip in the jet stream can cause a west to eastern snow push, and this is a perfect example. This is current time right now. The end of this loop you see is current time, and what I want you to focus on are two areas. This area right here that is pushing over the northeast part of Texas into Louisiana, and then eventually to make its way over Florida. And then I want you to look at this area right here where my cursor is. Now, you can see that these are basic U shapes, but I want you to see the wind direction and the water vapor movement here. You can see some of it's actually pushing into a northeastern direction right here. You can see that going up over the northern side of New York, the north coast of New York. But it's actually beginning in Canada. So you can see the loop. It starts up here in Canada, and then it's dipping down across the middle of the country, and then whipping down into the southern states. And that's why we have these cold temperatures going on. Guys, we had full snow in the panhandle of Florida, one of my commenters wrote, which I thought was crazy. And it just goes to show when the jet stream, once again, not just in hurricane season but in all seasons, is the determining factor in our weather, guys. So you can see right here, if you can get an eye for it, it takes a little bit for your eyes to adjust to this type of screen here. At least it does for me in the morning. But you can see this clear dip in the jet stream, and this is super low. This is over the north area of Texas, again, into Louisiana, and then it's going to push over the Mississippi and Alabama states, and then into Georgia. And that's what's actually causing this cold air to be pulled all the way down into areas of the panhandle of Florida. So in all reality, guys, we could see snow in any of these states, and we have been. We've been seeing a lot of snow. The Pennsylvania, northeast Pennsylvania got a couple inches the other day. Pittsburgh's expecting snow. We could get snow in West Virginia. But the main thing to look at here is that when you get these deep U's in the jet stream like this, that means that all the cold air in Canada is being pulled down. So with this defined U right here especially, you can see this is moving right over two of the Great Lakes, and then it starts shifting to the east. So you can see, just because it's a U shape, that doesn't mean that it's a straight down path and then west to east and then back up south to north. You can see the U kind of like whipping and sliding across the U.S. I kind of tried to describe this during hurricane season as well. As far as weather fronts and how they were going to push hurricanes out into the Atlantic Ocean. We dealt with that with Ophelia and Jose, actually. But again, here it is, guys. This U is going right over the Great Lakes of the U.S., and this is super cold air. So you can just picture this as different layers of cold air, and this is very low again, guys. That's why we're getting these cold temperatures all over the middle of the U.S. and even the southern states now. Snow in the panhandle of Florida. It's just that deep U will pull that air all the way down as far as it goes, and then you can see how drastic the weather gets in areas of the Northeast, like West Virginia, Pennsylvania, Delaware, all these areas, New York, Maryland, Vermont, Maine. And you can just see how once you get that little whip going on over the lakes, it just moves a lot quicker, and that's how you get that west to east movement. And that's also why we had that snow that was a little bit south of Buffalo and then south of Watertown. So you could be expecting more snow actually as early as today. I know northeast Pennsylvania is supposed to get snow, so I can only imagine that Pittsburgh and areas in western Pennsylvania might be seeing snow as early as a couple hours from now, if not already. But again, guys, this U right here, this defined U that's going over the Great Lakes, is super cold air, and it is moving moisture all over these states here. So that is why we are getting that snow. Now, I'll show you real quick. You can actually relate it to the GFS here on Tropical Tidbits. This is that deep U right here that we're looking at on the water vapor chart. And you can see how low it goes. It goes all the way down here, and it's pushing moisture into Georgia and Florida, and that's where we're getting those snow, the snow accumulations down in this area. It's not much, but it just goes to show how powerful the jet stream is. When it dips down this far, it will pull cold air all the way down into South Florida, or into Florida rather, which I just find very interesting. I just think the jet stream is crazy how it works, how it can make a warm climate state into snow. That's basically what I heard from some of my subs, and I thought that was really cool that they actually saw snow in the panhandle of Florida. But you can see the center of the low pressure is right over New York. And as we move forward from the 12th today into the 13th, you can see that moisture start to basically expose itself, and that's where we're going to have this slushy and snowy type of commute and stuff like that, but that won't be until tomorrow. So keep a heads up for that, especially in the Northeast. The brunt of this system is going to be over the Atlantic Ocean by the time it actually accumulates all that moisture, so that is a good thing. That may change. We just don't know. It's hard to tell this far out. And then you can see the clear low system right here, and then there's another low behind it, so we're going to see what that actually brings to us. But there you have it, guys. That's why that lake effect snow is working the way it does. Before I let you go, I want to show you this video, guys. This is the sun. This is an SDO camera, but I want you to look at the size of this plasma tornado. This is a tornado of plasma around 2.5 to 2.8 million degrees. Now I'm going to hit play here, and I'm going to show you a scale. This is twice the size of Earth, this tornado right here. This is current time too. This was in the last 48 hours. You can see it's actually the camera moving around the sun. The sun isn't spinning. It looks like it's spinning on an axis. It's actually a camera on a satellite moving around the sun. But you get a real good view of this tornado here of plasma, guys. That's how crazy the sun is. The sun can produce tornadoes twice the size of the Earth of plasma. Just check that out. And there was a little CME right there. You see that explosion? Right? Did we miss it? I think we missed it. Right there, you can see that little explosion. That was a mini CME, a little minor one. But look at this tornado. You can actually see it spinning. That's how big it is. It looks like just like a tornado you get in the middle of the U.S. That we were covering earlier. In those water spouts, you can actually see right through it and see the definition of this thing. I just find that very cool, guys. For those of you that are into the space weather, here we go. Tornado on the sun. Tell me that's not space weather right there. You can see the top whipping around. Very, very cool. And then I pulled up another version of the SDO. This is the A1A 304 camera, and you can see just the amount of plasma this tornado has in it. For those of you that follow these cameras and study them, you know what I'm talking about. This is a plasma reading. This is a filter they put on the satellite that reads the highest densities of plasma. You can see one here, one here. There's actually another tornado I didn't put in the Helio viewer video up in this area, which I thought was really cool. But anyway, any of you that want to check this out, just go into Google, type in SDO A1A space 304, and you get this camera, and then the other one is 194. So they have different filters for different situations. And then here's a picture just to give you an Earth scale. This is on the thumbnail. Again, this is from Helio Viewer. You can go to helioviewer.org and make your own videos and pictures. And this is an Earth scale right here compared to this tornado. Check that out. That thing is massive. Imagine seeing a tornado twice the size of our Earth. Just unreal. I bet if you had the right type of glasses, you might be able to see this on the side of the sun with those eclipse glasses or the welding goggles. I think that's all I have for you this morning, guys. I hope you all have a great morning. Drive safe for those of you in the crappy weather. This afternoon I should have another video out. If not, we will talk tomorrow morning, and we will talk about the commute. All right, guys, have a great day. Thank you very much.